Hi, Rick Wallace here for the Pareto Environmental Education Center in Los Alamos, New Mexico. Today we will talk about just what is this upcoming summer solstice and what causes the seasons from an astronomical perspective. Then in a subsequent video, part two, we will discuss a few current and historical celebrations around the world that are associated with the summer solstice. Now, one of the primary characteristics of the summer solstice is that you have a large number of hours of daylight. So as you move north, you see that the number of hours of daylight, and here it includes the civil twilight in these numbers, gets larger until you reach the Arctic Circle. And as you can see in the inset of Hawaii here, once you get above the Arctic Circle, you actually have 24 hours of daylight. Here's another way of looking at that. You can see the numbers of hours of daylight on each of the red lines here until it approaches the Arctic Circle where the sun never sets. And this is an example of that. This is the sun during the day, or approaching midnight now actually, in Alaska above the Arctic Circle, where the sun never actually sets below the horizon. A few summer solstice facts. The summer solstice arrives in the Northern Hemisphere near June 21st, which is also the longest day of the year. The date of the earliest sunrise is about a week before the solstice, and the latest sunset occurs about a week after the solstice. This mismatch occurs for two reasons. The Earth's orbit around the sun is slightly elliptical, so Earth travels at different speeds during the course of the year. It moves fastest when it's closest to the sun and slowest when it's farthest away. Right now, Earth is near the far point of its orbit, so it is traveling more slowly than average. But it spins on its axis at the same rate all the time, 24 hours per day. So no matter where it is in its orbit, these two differences in orbital motion and rotation affect the precise time of sunrise and sunset. The Earth's rotation axis is also tilted 23.5 degrees. This affects the time of sunrise and sunset as well. As a result, the earliest sunrise of the year happens before the solstice. The exact date depends on your latitude. Here you can see that this year, 2020, the summer solstice in Santa Fe or Los Alamos occurs on Saturday, June 20th, where we will have 14.5 hours of daylight, almost 5 hours longer than in December. The earliest sunrise will occur on June 12th, and the latest sunset on June 28th. Now, the warmest day of the year is usually around July and August within the US, and the coldest days of the year are around January or February. The warmest days depend on the bodies of water nearby that absorb heat and gradually release it. For example, the warmest day in San Francisco is typically in September, whereas here in New Mexico, we are pretty far from any oceans, and so the warmest day is usually the end of June, and the coldest days are usually in late December or early January.
Seasons are broadly characterized by the difference in average temperature and the length of day or night. Intuitively, it may seem that the varying distance of Earth from Sun causes seasons, but in fact, the maximum difference of this distance is just about 3%. The real cause of seasons is the tilt of Earth's rotational axis relative to the plane of revolution. When the northern hemisphere is tilted towards the sun, it has longer days, receives more of the sun's rays, and the sunlight hits more directly. This happens around June every year when the northern hemisphere has summer and the southern hemisphere has winter. Conversely, around December, the northern hemisphere is tilted away from the sun, thus experiencing winter. These extremes, when the poles are either farthest or closest to the sun, are called solstices, when we have the longest days or nights. During late March, both the hemispheres are at equal distance from the sun, and thus have an equal length of day or night. This is called an equinox, and it marks the beginning of spring in the northern hemisphere and autumn for the southern hemisphere. Similarly, in late September, we have another equinox heralding the other two seasons. Note that solstices are not the position when Earth is closest or farthest from the Sun. In fact, Earth is closest to the Sun in January.
Now let's explore a little bit more about the angle of the sun's incoming radiation and how that affects the seasons.
During the summer in Illinois, the position of the Earth to the Sun makes the north half of the Earth tilt towards the Sun. This makes the Sun appear higher in the sky. The higher the Sun, the more direct sunlight hits the Earth. This concentrates sunlight into a smaller area, causing more heating. Think of a flashlight. If you shine a flashlight at a 90-degree angle to a wall, you get a small circle of light. If you have the flashlight at a smaller angle, the circle of light becomes larger. The amount of light or energy the flashlight is putting out is the same, but the energy is spread out over a wider area. The same thing happens when sun angle is less than 90 degrees. The energy is spread out over a wider area and won't cause as much heating. 6 months after our summer, the Earth has moved, and now the north half of the Earth is tilted away from the Sun. Sun angle is lower, with less heating. We're in winter. Think about where the noon sun is in the sky in summer compared to winter. You'll notice the noon sun is much higher in summer than in winter. Each day, the sun angle changes ever so slightly. After the first day of winter, the sun gets a little higher each day until the first day of summer. After the first day of summer, sun angles slowly get lower. Daylight length plays a much smaller part in seasonal change as compared to sun angle. During our summer, we get more hours of daylight than at the equator, but the equator is still warmer because sun angle is higher there. The poles have 24 hours of daylight for 6 months of the year, but they are still cold during that time. That's because the sun never gets high in the sky at the poles.
Now we will explore an actual photograph of this effect. Here is the Earth from NASA satellites with a number of photos put together. This covers the entire year. So you can see now it's approaching in the Northern Hemisphere summer. Back to equinox. We'll play it again, because that went by fairly quickly. Equinox in the autumn. Now it's winter in the Northern Hemisphere. Spring equinox, summer in the Northern Hemisphere, and back to winter. Now remember that the Earth is revolving, orbiting the sun during this time, although you can't really tell it from the way this satellite composition is created, but that's what's causing the varying angles of sunlight during the year, as shown in the last couple of videos. Now, other planets also have seasons depending on the tilt of their rotation compared to the plane of their orbit around the sun. The Earth, Mars, and Saturn, for example, are all tilted around 23 to 26 degrees and have very similar seasons. Mercury, Venus, and Jupiter, on the other hand, have almost no tilt to their rotation, and so they don't have seasons the way we do here on Earth. This shows the point on the horizon where the sun rises during the year, and the height of the sun at noon, its highest height in the sky. And you can see that as we move towards summer, this point of sunrise moves farther and farther north. At the same time, the sun is getting higher and higher in the sky at noon each day. So that gives you an idea of what causes the seasons, and in particular, the role that the solstice, the summer solstice, winter solstice, and the equinoxes play in this activity. Also, there are many celebrations around the world that are related to the summer solstice because, especially in earlier days when more of human activity was tied to agricultural seasons, knowing when the summer solstice was very important. So in a subsequent video, we will explore that.